The issue we turn to now is the question of what energy is, and in particular, how did the scientific concept of energy evolve? And remarkably, as we will see, even today we don't fully understand what energy is. But the key origin to understanding energy was the concept of the conservation of energy. That is, that nature can transfer energy from various different categories: kinetic energy, potential energy, chemical energy, electrical energy, thermal energy, and do so with remarkable accuracy such that the total energy remains conserved. That is, the change in energy amongst and between all of those different categories results in a total change of energy of zero. And that's the principle of the conservation of energy. So the question was, how did this understanding evolve? Because until science understood what energy and energy conservation was, actually there was very little progress made. And it was the middle of the 18th century that the concept of energy and the conservation of energy became clear. The next issue is the question of potential energy and the way in which physical bodies roll on a potential energy surface, for example, up over a hill and back down the other side, and the direct connection that has to a reaction coordinate in chemistry. We'll see those principles tie very closely together. And finally, we're very interested in understanding the orders of magnitude of energy, but we're also interested in understanding the orders of magnitude of power. And the relationship between power and energy, it turns out, is extremely important, because power is the conversion of energy per unit time. And so power equaling energy per unit time allows us to step back and forth between the orders of magnitude of energy and power. And as the famous scientist Fermi pointed out, the difference between an educated scientist and an amateur is one that understands and can link the orders of magnitude in energy, in power, in time, and in space. So we turn to the question, what is energy? We're going to explore the categories that comprise this concept of energy. And we're going to see that there are two forms of mechanical energy: kinetic energy and potential energy. There's electrical energy, chemical energy, electromagnetic energy, thermal energy, and nuclear energy. And we're going to explore not only what these different categories are, but also how they relate to one another, and how nature exchanges energy amongst and between these different categories seamlessly, accurately, such that the total amount of energy in the universe is conserved.